Today, I'll be talking about my arc length project. So let's get into it. So let's talk about the path a little bit. So this is a path around the Glenridge Country Club in Glenridge, New Jersey. I think I passed by this when I was a little youngin, and I thought it was pretty luxurious, and I wanted to be a member of this exclusive club. Uh, I don't golf though. I think I would just walk around the club and take some laps, as you can see detailed here. So let's talk about how to measure that path length. So the path can be broken up into four different segments. Three straights, one near the parking lot, one side length, and one right before, this little curve. And then the actual curve itself, the polynomial equation on the side. So you can just measure the three straights using the measurement tool on Google Maps. You get this length, which is around 475 feet. This one, which is around 150, and this one, which is around 83. So all three of those equate to around 708 feet. So you add that plus this length right here, which I outlined in blue, this polynomial equation length, this little arc. So we have to find that arc. So how do we find that? So to find that, I plotted points, which will be plugged in later using a regression calculator. You see, I started here at the beginning of this little arc, at the origin 0, 0, and it's increasing a bit, and this is a local max of it. Then it decreases from here, and it kind of decreases slowly. It kind of it levels out around these 2 points, and then it decreases steeper again around here, and then we have the final point, which is right here. So in total, I used around 7 points, so it can be more accurate. So now, the regression. Instead of using the graphing tool, the graphing application that was recommended, I used Desmos because I thought that it would be easier and more accessible. So, how exactly did I use Desmos for it? So first, I plotted the points and put it in a little table here, right here, as you can see. And then after that, I used an equation that I found would actually match the arc the best, and it's seen right here. To get this equation, I just had to play around with the powers, and eventually I ended up with a 6-degree polynomial that is not exactly, it's you wouldn't really find this without experimenting with it. So it's kind of a tedious process, but eventually I found it, and it actually does match the path pretty well. As you can see with the r squared value, which is 0.9999, meaning that this is basically an almost perfect match to the actual path. And as you can see here, it's pretty similar, man. You can see. Yeah, so it's pretty similar, which is good. Means we'll get the most accurate result out of this polynomial here. All right, so now let's actually calculate the arc length. This is the equation we got from the regression. As you can see, these coefficients were provided in the parameters, and we just need to take the derivative of this, which equates to this. Equates to this right here. And then you just plug this into the arc length formula. You can see the formula of the arc length is the definite integral from 0 to 396, because those were my two bounds if you want to go back and look at it. See? 396 and 0. And then after we do that, it's the definite integral from those bounds to the square root of 1 plus the derivative, which we already calculated, squared dx, and we get an answer of 565.47 feet. So in total, we can conclude that the total path length around this country club is 1,273 feet. Thank you for listening.